Right, hi guys, good evening and welcome back on another video. Right, so today I'm going to teach you how to create a C-grid topology on a pointwise pointer. Alright, so in this case we're going to use C-grid. We're going to create a C-grid but using extrusion technique. Right, now first of all, over here I have a NACA 2412 but on a sharp edge airfoil, because later on when we create a C-grid topology there's going to be a trailing edge, there's going to be a straight line coming out on the trailing edge, right, as it's going to help the C-grid topology. Right, now first of all we're going to create points for this airfoil. Right, for us to create those points we have to set the dimension over here, and I'm going to set the dimension to 51. Right, I have set it up already. Right, once it's done, then now I'm going to create layers for it to show the pointers. Right, so over here we just have to create database, click on database, highlight the whole thing, right, and then click on connectors on database entities, and then click on connectors, right, and then turn on the points. Right, so as you can see I've turned on the points, right, but however if you see clearly, right, the points are not sitting on the airfoil. Right, so what do we have to do? Right, what we have to do is that, as I taught you in the previous video, we have to use connector constraints, right, like this over here, spacing constraints. Right, so what do? We just click on the spacing constraints, right, and then highlight the top and bottom part, right, and over here for the leading edge we're going to label it at 0. Right, we're going to label it at 0.001. Right, then hit enter. See, it sits on the points already. Right, and then over to the trailing edge I'm gonna label it as over to the trailing edge I'm gonna label it as 0.001. right, 0.01, I'm sorry. Right, now everything is set. Right, over here you can see everything is set up clearly, neat and nice. Right, and that's for the airfoil pointers. Alright, so next we have to label the default part again to 101. Right, once that is done, then we have to click on, right, the pointers. Right, this is what we call 2-point curve. So over here I'm just going to click on the trailing edge, right, and on the x-axis part I want to label it at 50. Right, so that it goes out as I told you, on the x-axis, right, it will leave out 50 chord length. Right, so if I zoom out, this is the total length that you will view. Right, so that is what defines the dimension for the C-grid topology, which means I'll get a nice straight line and then I'll get a curve over the airfoil. Right, so that's the important part of that topology, of that straight line. Right, so next I want to see some points over the the straight line. Right, so what am I going to do? I'm just going to click on connectors and I'm just going to click on the spacing constraints, and I'm just going to highlight on the straight line that we just created, right, and click on the spacing constraints, and luckily the value that we clicked on just now is still the same, so I'm just going to hit enter, right, and then turn on the pointers. Right, so now if you can see, it's the same as our x-axis and y-axis. Right, so it's the same as the values that we have hit here. Right, that's the main important part. Get me? Alright, now that's the important part that we really need over here. Right, alright, so now it's the same, it's a similar one that we have clicked in and hit on. Right, now the next thing that we have to do here, right, is to create a C-grid topology. Right, to create that we're going to use an extrusion technique, as I told you before. Right, so that's the important part that we have to follow. Alright, now you may ask me why 50. I'm choose 50 because later on when I create a C topology, the general idea of a topology is to have 100 dimension in front. Right, so to significantly support the values and significantly collect all the mesh data, right, we need to have a clear straight distance from the airfoil of approximately half of the chord length in front, which is on the C grid, right? So that's why I choose 50, and later on we will extend the whole dimension in order to get a wake section to collect all the after effects from the foil, so which will give us another block dimension of another 50 or another 100 length, right, which will collect all the wake effect from the airfoil's inlet flow. Right, now the next step is going to be, right, creating an extrusion, which I'm going to use on a normal section, right? So if you can see here, right, I have not selected properly, so I'm just going to cancel that, right? I'm just going to highlight the whole thing. I'm just going to create, extrude, and normal, right? I'm going to create on an assemble special. I'm just going to delete all the edges, right, and I'll be selecting all of the edges on my own, right? So over here we'll be relying on the control button, so click on it carefully. So we'll start from the trailing edge, right? So over here what we'll be doing is that we'll be creating on our own, right? We're not going to be following on the auto assemble. Therefore I'll be clicking it from the branch connectors, right? This one, hold your control here, right, and then the top part, the bottom part, and back to the branch connector, right? So that's what I'm satisfied upon, and then I'm just going to click on save edge, right, and then I'm just going to click on done. So if you see here, all the values on the arrows are quite satisfiedly placed, right? Now over here it's obviously flipped inside, so I'm just going to flip outside. Now it's clear to see, right? Now the first thing that we're going to do is that we're going to set up a boundary condition, right? Now when the moment you click on boundary condition, why we are doing that is because we want to extend the value later on from the branch connector's edge part outward even further, correct? So I'm just going to highlight that part, right, and I'm just going to click on X constraint because it's on X-axis, right? This is our X-axis, right? And if you don't do that, it's just going to splay out outwards with all the after effects without being constrained in a boundary, in a box, right? So instead of doing that, what we'll be doing is that we'll be clicking on that point and selecting constraint X. And then when I set the boundary, it's fixed. So later on when I extend that section, right, it's easier for me to create a box, right? Now back to the attribute part, right? So over here we'll be playing around with the step size, orientation, the stop condition, right, and also the smoothing parameters, right? That's the main thing that we'll be doing, right? Now the step size, the thing that we'll be playing upon will be the initial spacing. Initial spacing follows our y plus parameter that we have adjusted according to our previous video on our O grid, right? We're just going to follow that 1 e to the power of -5, right? And then our growth rate will be 1.2. do not adjust that, right? And then our total height on this range is going to be 120, right? We can adjust that according to our own preference. So for the beginning part, I'll be playing with 120, then later on I'll be changing that to 150, right? Or you can just begin with 100 and see the changes later on. Let me show you, right? Now for the volume part, let's begin with something small, then we change it back to something big, because the initial part, volume smoothing, is very important to equalize the volume of element on the extrusion front. Otherwise the volume will be weirdly placed and we will be not able to see the clear picture on the C grid, right? So we'll start from something visible from 0.01, right? Now we'll go back to the run part, right? Over here I'll just run on 40 first, right, just to see on the volume, right? So if you see the 40, right, the 40 creates a volume of something that's a bit weirdly placed, right? This is not something that I would like to see on an aircraft, on an airfoil. So what I'll be doing, I'll be changing that, right, and I'll be changing the attributes one more time. So I'll be changing that to 150, right, and then I'll change that to 0.5, right, and then back to the orientation run. This time I'll just put 100, right? We'll try to change the run, right, and it will stop at 1 point, where it creates a good C, right? So that's good enough for me, right? So the whatever extra I can just delete it, and this is what we get, right? So if this is good for you, you can just click OK. Otherwise, if you want to change the volume and play, hit run again, change the total height, hit run again, it's up to you. You can just adjust it on your own, right? Then press OK on it, right? Alright, and to be clear, the total height thoroughly depends on the chord length that you use, right? If you want to change the chord length, right, that depends on the dimension of the airfoil and the NACA as well, right? So be careful on it, right? Now, once this is done, right, once this is done, we're going to play around for the next part, which is the extended part, right? That's the important version. Right now we are on the final part, which is to create the extension wake section, correct? So over here I'm just going to deselect the constraint part, and we're going to display that from this connector and this connector, correct? So click control and click on both of that part, right? Click control, click on both of that part, right? And then go to create extrude and create a translational extrude assemble, right? So I like that part, so save that, done, right? Now we're going to play around on the x-axis, and on our x-axis I want to put it on 100, right? Put it on 100, and this time I want to make a step run of 20, right? 20 is enough for now, so I'm just going to run, right? So if this is enough for you, you can stop there. Otherwise, if you want to extend that part, you want to make it 150, right? You can run that again, it will extend further, right? So if you ask me, I do not want an under 50, so I just keep it at 100. So I just run it at 100, right? So I just run it at 100, right? So 100 is enough for me, and 100 is good enough for me, right? So if you do not want to, if you want to see that again, if you see here, right, the moment I click 100 and use x-axis, I'll see a yellow line here, and then all I have to do is insert 20 on the step, and then I hit run, right? So that's all. That's good enough for me, right? Now the next thing that I would like to see is, I would like to understand the distance between both of these lines, right? The both of these lines have different dimension selected on it, right? Now we have to adjust that. I'm a bit picky on that since I have a little bit of OCD, right? So what am I going to do? I'm just going to change that dimension, right? So I'm just going to hit control, and I'm just going to go to grid, and I'm just going to go to dimension, right? And we're going to go to dimension, right? Oops, sorry. Grid, select that and that, go to grid, go to distribute, then go to dimension, right? Sorry, change the function first, change the function to tangent, right? Once you change the function to tangent, apply the equal spacing, right? Once you apply the equal spacing, go to spacing, right? Change the spacing, right? So over here, what do you want the spacing to be, right? So if I look closely, right, if I look closely, this spacing to this spacing is going to be, right, this spacing to this spacing is roughly on 3 dimension, right? So how do I know that? I made a measurement for it, right? And I made a measurement for that, right? So when I take this calculation and this calculation, I'm just going to hit on 3, right? I'm going to hit on 3.0, right? So then I'll just apply, and it changes the whole dimension. I'll just hit OK, right? So if you look closely now, it's a bit close enough, right? Now if you do not want to do that, right, you can just flip the mode backwards and check if the dimension is same. Then you can just play around with the dimension once again, right? You can play around with the one dimension once again, right? Then we can make it to another dimension according to the similar size of equivalent length. Alright, so I'm just going to change the dimension back again to something closer to that. If you are not, and if you're okay with the drawing and you're okay with the dimension, then I don't mind actually, right? If you're okay with the drawing and you're okay with the dimension, then you don't have to worry about it, right? You thoroughly have to, right? You thoroughly do not have to worry about it, right? If you're like me, you just have to do a simple distribution, right? Tangent, and then select on spacing, right? Change it, right? and then now it may be equivalent. Yeah, see, it's almost same, it's close enough, right? Now that's what I want, right? So that's about the C grid conclusion, right? C grid using extrusion technique. And if you can see, all the airfoils value is quite clear, the topology is well created, and if you can see, all the C grid values have been created in a splendid manner, right? So if you have any questions, do let me know in the comment section, or I can make another video of H grid and show you how to create a H grid topology, right? So that's about it for today. All right, thank you, we'll see you soon.